So ReFS is a file system that is based on the NTFS file system. It provides the following advantages over NTFS. Metadata integrity with checksums, expanding protection against data corruption. It also maximizes reliability, especially during a loss of power, while NTFS has not known to experience corruption in similar circumstances. It also provides large volume file and directory sizes, storage pooling and virtualization, which makes creating and managing file systems easier. It is redundant for fault tolerance, disk scrubbing for protection against latent disk errors, resiliency to corruption with recovery to maximum volume availability. Also, shared storage pools across machines for additional failure tolerance and load balancing. Also, ReFS inherits some features from NTFS, including the following: BitLocker, ACLs for security, update sequence number or USN journal, change notifications, symbolic links, junction points, mount points, and reparse points, volume snapshots, and file IDs. ReFS uses a subset of NTFS features, so it maintains backward compatibility with NTFS. Therefore, programs that run on Windows Server can access files on ReFS just as they would on NTFS. However, an ReFS formatted drive is not recognized when placed in computers that are running Windows Server operating systems that were released before Windows Server 2012. You can use ReFS drives with Windows 10 and Windows 8, Windows 11 of course, and all subsequent Windows operating systems. NTFS enables you to change a volume's allocation unit size. However, with ReFS, each volume has a fixed size of 68 kilobytes, which you cannot change. ReFS does not support encrypted file system or EFS for files. As its name implies, the new file system offers greater resiliency, meaning better data verification, error correction, and scalability. So, compared to NTFS, ReFS offers larger maximum size for individual files, directories, disk volumes, and other items, such as maximum number of storage pools, number of spaces, maximum file name length, and so on. So ReFS is ideal in the following situations: Microsoft Hyper-V workloads. ReFS has performance advantages when using both .vhd and vhdx files. Storage space is direct. In Windows Server, nodes in a cluster can share direct attached storage. In this situation, ReFS provides improved throughput but also supports higher capacity disks used by the cluster nodes. And archive data. The resiliency that ReFS provides means it is a good choice for data that you want to retain for longer periods. It can also be used for such scenarios as Exchange logs, drives, and so on. Now, as you can see, we've got in this wizard to create a new simple volume with ReFS formatted. But it is not recommended to do so. Don't use new volume wizard when creating ReFS volumes. It doesn't give you the option to disable ReFS integrity systems at the volume level. If, for example, you want to create ReFS file system for the volumes for keeping exchange logs or some other logs when you don't need this ReFS integrity. And it doesn't give you the possibility of flexible configuration of your new ReFS formatted disks. So it's best practice to create ReFS volumes, and of course it's related not only to ReFS volumes, but to working with disks, it's better to do with PowerShell. It's more flexible, it's faster, and you can repeat the needed commands in a matter of seconds. To set it at the volume level itself, use PowerShell when configuring new volumes. So, first let's get information regarding the disks in the system, and we'll do it with the get disk commandlet. So let me switch to PowerShell ISA. I've launched it with administrator privileges, and I'll type get disk.